Surface Plasmon Resonance, a video project by Domingo, Zairus, Gorada, Cezar, and Lamitar, Jash. How was surface plasmon resonance discovered and who were its pioneers?
Surface plasmon resonance was first discovered by Sir Robert W. Wood. So between 1902 and 1912, Sir Wood at Johns Hopkins University noticed that when he shone polarized light into a metal back diffraction grating, a pattern of unusual dark and light bands appeared in the reflected light. So in the first theoretical treatment of these anomalies was formulated by Lord Rayleigh in 1907. So he based his dynamical theory of grating on the expansion of scattered electromagnetic field in terms of outgoing waves only. So for further researches, Sir David Pines and Sir David Bohm suggested that the energy losses were due to the excitation of conducting electrons, creating plasmoscallion or plasmons. So further researches revealed that the energy loss resulted excitation of a surface plasma scallion in which part of restoring electric field extended beyond the specimen boundary.
How was surface plasmon resonance developed? In the late 60s, optical excitation of surface plasmons by means of attenuated total reflection was demonstrated by Crushman and Otto. Thereafter, there have been two major approaches to optical excitation of surface plasma waves: attenuated total reflection in prism, coupler-based structures, and diffraction at diffraction gratings. The first approach is the application of surface plasma waves excited by the attenuated total reflection method for sensing, also known as SPR immunoassay, have been advocated by Nylander and Leibberg. Due to its simplicity, this method has been widely applied for characterization of thin films and biochemical sensing. The second approach is the use of diffraction grating-based systems for SPR sensing, has been pioneered by Cullen et al. The grating-based surface plasmon resonance SPR sensors have been studied as an alternative to prism-based systems. In the 1980s, surface plasmon resonance SPR and related techniques using evanescent waves were applied to the interrogation of thin films as well as biological and chemical interactions. These techniques allow the user to study the interaction between immobilized receptors and analytes in solution in real time and without labeling of the analyte. By observing binding rates and the binding levels, there are different ways to provide information on the specificity, kinetics, and affinity of the interaction, or the concentration of the analyte. How does surface plasmon resonance work?
There are many functional proteomic technologies that require time-consuming labeling steps and still have an inconsistent probability whether the proteins will interact or not. Surface plasmon resonance allows for label-free detection in real time and provides rich information about the interaction kinetics. Surface plasmon resonance is a phenomenon that occurs when polarized light hits a metal film at the interface of media with different refractive indices. SPR techniques excite and detect collective oscillations of free electrons known as surface plasmons via the Crushman configuration, in which light is focused onto a metal film through a glass prism and the subsequent reflection is detected. A light is incident upon a metal film through a prism and the reflected beam is collected and analyzed. Certain angle, the plasmons are said to resonate with light, resulting in absorption of light at that angle. This creates a dark line in the reflected beam. That dark line contains a wealth of information. The resonance angle can be obtained by observing a dip in SPR reflection intensity. A shift in the reflectivity curve represents a molecular binding event taking place on or near the metal film, or a conformational change in the molecules bound to the film. By monitoring this shift versus time, researchers can study molecular binding events and binding kinetics without the hassle of labels. The angular shift versus time provides a good study of binding kinetics. The reverse process, molecular dissociation, can be studied in a similar way.
Latest updates about surface plasmon resonance.
So, the latest updates about surface plasmon resonance is it is used in the impact of natural modes in plasmonic imaging. So, plasmonic imaging is crucial for understanding cellular behaviors for biological sciences, where it is used to image and track organelles in cells, so such as DNA and viruses. Due to the fast dynamics of the intracellular processes, it is essential to keep the cells under their native states. So, establishing plasmonic imaging as one of the most powerful tools for studying biological samples. So, another use of surface plasmon resonance is in nanostructure-based plasmon-enhanced Raman spectroscopy for surface analysis of materials. So, the mechanisms of PERS and discuss PERS hotspots. So, nanoscale regions with a strongly enhanced local electromagnetic field that allows trace molecule detection, biomolecular analysis, and surface characterization of various materials. So for the last update of the surface plasmon resonance, it is the amplifying the signal of localized surface plasmon resonance sensing for the sensitive detection of E. coli. So the obtained gold nanorods based on LSPR sensor was further used in practical application for selective detection of E. coli, and the detection limit achieved is 10 CFU, which is much lower than the conventional methods such as electrochemical methods and lateral flow of immunochromatography.
Listed below are the credits and citations. Thank you for watching.